Hello, so today I'll be trying to tackle this tricky geometry problem. So, it's asking you to find out the shaded area, which is the yellow part, and you know the side of the square, which is 1 meter. This might seem a bit perplexing at first, but you could notice that this is not made up of like some flowery shapes. I mean, it kind of looks like a flower though. It's actually made of quarter circles. I'll show you here. That's 1 quarter circle. This is another quarter circle. That is another quarter circle. And I think I've run out of colours. This one is another quarter circle. So knowing this information, we only need to work out one segment, which would be like this, to work out the rest of the segments, and then we'll have a square, which is, a pretty nice thing to work out. So first thing I'm going to do is I'm going to split these into 3 equal triangles. These are equal isosceles triangles. And one thing we know is that this is a quarter circle. So that means the angle over here is going to be 90 degrees. Since we have 3 of these triangles which are all equal, that means their top angle, I'm going to call, or non-isosceles angle, is going to be 90 over 3, which is 30 degrees. So we know the base of each square, it's all the same, all the lengths. So that means this one is 1. And as I said, this is an isosceles triangle, which means that this side is also 1. So right now we have ourselves a sector, and we can work out the area of that. So that's just going to be 30 over 360 times pi times 1 squared, which is pi over 12. And now to find out the area of the segment, we have to take it away from the area of this triangle over here. So try, I call that half times 1 squared times sine 30, which gives us a quarter. So for the seg, we're going to do pi over 12 minus a quarter, which gives us pi minus 3 over 12. So here, as you can see, we don't just have one segment. We have 4 segments over here. So what we do is we're going to times this by 4. And we're going to get pi minus 3 over 3 as our segment area. I'm going to try and rub some of this out now. Okay. So, after we work out the area of the sectors, you'll find that we're left with a square that's really poorly drawn. Okay. So this might seem a bit tricky to work out, but you could just use this cosine rule, because we know this side's 1, this side's 1, the angle between them is 30. So the cosine rule, we're going to have 1 squared plus 1 squared minus 2, 1 squared, cosine 30. And that's going to give us 2 minus 2 cos 30, which is 2 minus root 3. That equals, I'm going to call it opposite squared. So, what we do to find the opposite is just 2 minus root 3, and then we're going to square root that. But over here, the area of a square is length times length, and since the lengths are the same, you just square this, which gives you back to 2 minus root 3. So we have 2 minus root 3, area of the square. We also have the area of the segment, so now all we do is just add it up. So now we get plus pi minus 3 root 3, which is times that, 0.315 approximately.